So in demonstrating the first piece, students kind of freak out when they look at the longer chart. So we're going to break it down for them piece by piece. First thing we're going to look at is our given, which is 1.118 grams of fructose. Now I'm going to use the words here rather than the chemical symbols. They're asked for in the problem how much water is produced. So grams of water. And the first thing we want to do is fill those in their proper place. So students know that the starting information goes in the top left. That even though we're doing multiple steps, we're going to be finishing with grams of water. So now we have to look at how are we going to get there. So if fructose starts here, we know our grams of fructose are going to have to be on the bottom. So the students had already figured out after their quiz the molar mass of fructose. So they put the mass on the bottom, 1 mole of fructose on top. Now the part that students tended to get confused on this year is the mole bridge. So I would have students go ahead and they know that moles of fructose have to cancel, and when they look at the chemical formula, or the equation, I'm sorry, they see that there's 1 mole of fructose in the chemical equation. But sometimes they get stuck about what goes on the top. And the trick I found this year is then to look at your end point and work backwards. So we knew we were going to have to end with the grams of water. So in this case, the 18.05 grams of water, and that's grams per mole. And the trick that helped students was to start working backwards from here so that they could identify diagonally that the top of the mole bridge had to be moles of water. And in our chemical equation at the top, it's 6 moles of water. That working forward and then backwards got many of my students unstuck as the year went on. Then once they have the full setup, we talked about how they can see each piece of the puzzle. So fructose, grams canceled, moles of fructose canceled diagonally, and then moles of water canceled diagonally, leaving us with grams of water and grams of water.